Very good morning, everyone. In this video, we will see how to calculate the gear to thickness using constant chord method. We will derive the relation for constant chord when in case of gears. So we have already seen how to measure gear to thickness using gear tooth vernier, and we found that both chordal addendum and chordal thickness were dependent on the number of teeth. So in case if we are interested to measure the gear to thickness for gears having different number of teeth, that will result in a laborious and time consuming calculations. Okay, so to overcome that problem we can go for constant chord method. So this constant chord method addresses the shortcomings of gear tooth vernier caliper. Okay, so now let's understand what is constant chord with respect to this diagram. This orange color is the gear, and this black color line, one second, this black color line is nothing but the rack, as it is written here, rack form. Okay, so these two gears engage. When these two gears engage, they make contact at point A and B. The line joining the points A and B is nothing but constant chord. It will be same for all gears irrespective of the number of teeth. So we will measure the gear to thickness along AB. Okay, this is what we are going to do in this video. Before that, before going to the derivation for this constant chord, we will see and we will try to understand some of the terminologies given in this diagram. This blue color circle is the pitch circle of the gear, and dotted circle mentioned in black color is the base circle of the gear. Likewise, you can see this D, it is nothing but the pitch line of the rack, and it can be seen from the diagram. This pitch line of the rack is tangential to the pitch circle of the gear. Okay, these two things we have to keep in mind. And this pi is nothing but pressure angle. Okay, so with this information we will go to the derivation part for constant chord. As you can see in the diagram, PD is nothing but arc PF from the picture. Let's write that. PD is nothing but arc PF. Okay, so what is arc PF? Arc PF, this is nothing but 1/4 of circular pitch. If you remember before, okay, this arc distance from this point to this point, this arc length we call it as pitch, circular pitch from here to here. So in our question, in our diagram, we have considering only this portion, which is nothing but 1/4 of the circular pitch. So replace it as 1/4 of circular pitch. So circular pitch we know that is pi times pitch circle diameter by number of teeth. Okay, so we know that pitch circle diameter by n is model. So PD is given as 1/4 pi m. Okay, angle CAP is also pi, as it is shown in the figure. Okay, since the line AP is the line of action, it is tangential to the base circle, hence angle CAP will also be pi. Okay, angle CAP also pi. Now we will consider two triangles separately. A D P A D P. This triangle I am considering. This angle is pi, hence this angle also will be pi. Okay, so let's try to find cos phi, which is nothing but AP by PD. So AP will become PD cos phi. Okay, so we have already found out what is PD here. PD is nothing but pi m by 4. Replace PD by pi m by 4 cos phi. Next we will take triangle PAC. This is pi AC P. Again apply cos pi is nothing but AC by AP. AC is nothing but AP by cos pi. We already found out what is AP, so it is pi by 4 m cos phi into cos phi. So it will become 5 by 4 m cos square pi. Okay, AC. From the picture we are interested to find only this AB, which is nothing but constant chord. AB is nothing but 2 times of AC. So AB, which is nothing but constant chord, that is equal to 2 times AC. So it will become 2 pi by 4 m cos square pi by 2 m cos square pi. So this is the relation for constant chord. Okay, you can see that it depends upon two terms. One is module, another one is pressure angle. Okay, so it overcomes the disadvantages of gear tooth vernier, where the chordal thickness and chordal addendum dependent on the number of teeth. Okay, so that shortcoming, that disadvantages can be overcome by measuring the gear tooth thickness based on constant chord method. Thank you.